Hey guys, so here's our last rule that we're going to look at for now. This one is called the quotient rule. Quotient, just a fancy word really for division. Okay, so let's not get confused by that. But we now have to use what we know before. So let's take a look at number 7 here, and you're all probably thinking to myself, this looks like nothing that we've done. But I would remind you, what do we really see in the first part here? This is just the product rule. That's all I want to do. So what has the same base? And if it's got the same base, we know what to do with our exponents. So we can combine our x's. Okay, I would say when we combine those, that will turn into x cubed. What do we do with our exponents when we have multiplication or the product rule? We add our exponents. So I would say this will turn into x to the 6th. I don't have any other y terms, so our y term just stays put like it is. Alright, we can rewrite this. This is all now over 4x squared. Okay, actually, no, I'm going to write that in a different color because I want to, and sometimes it's easier to see. So I've got my x's in our numerator. I've got a couple of x's in our denominator. Do I have any y's? Well, I've got y cubed in my numerator. I've got nothing in my denominator. So let's go ahead, and if it helps you, I'm going to put a 1 right here in front of that x to the 6th. I just got rid of it, and now it's back. Whew. Okay, so let's go from here. My quotient rule. This is our fancy math right here. So if I have x to some power a, and I'm dividing that by x to a power b, all I have to do is subtract those two, and we're left with our answer. Now in subtraction, of course, order does make a difference. So let's do this. I'm going to leave my 1 in my 4th. We can leave that as a fraction. This will turn into x to the 6 minus 2. And I'm still left with y cubed. So if I wanted to write this whole thing out, I could say that this turns into x to the 4th power. This turns into y to the 3rd power. And this is all over 4. There we go, we're done. We have positive exponents everywhere. I can't divide anything. I could have a 1 right here, but it's really not necessary at this point. Let's go ahead and let's look at number 8. Number 8 looks pretty scary because, once again, there's a lot going on. There's nothing for me to simplify in my numerator. There's nothing for me to simplify at all. So let's just leave that alone, and let's focus our attention down here on the denominator. So I have an x that's a base. I also have another x that's a base over here. And I've got a couple numbers that I can combine as well. 2 times 4 is going to be 8. What do we have on our x's? This is a negative 1. And I'm going to add to that a 2. My y, I just have one y all by its little lonesome. And I really know that it's y to the 1st, so we could write that out there. Alright, so if we write this out like it is, so I'm going to have 8x to the, well, negative 1 plus 2. That's just x to the 1st. And this is y to the 1st. So this right here is what we get when we simplify all of that. Now, because my space is limited, watch this. We are going to get rid of all of this, and I am now going to bring this back down into our fun here. Actually, you know what? Let's keep the color coding alike because sometimes it makes it a little bit easier to see what pairs up with what until we really can get the hang of this. Okay, and we have this random line going on right there. Okay, now maybe it's a little bit easier for you to see what we're going to do. So we have combined this bottom stuff, gang, and it turned into this. Then I brought my numerator back down. Alright, it's over here now. Now we can do what our quotient rule tells us to do, which is when we have things of the same base, we can just subtract them. 3/8. Can I simplify 3/8 if we think of it like a fraction? Well, the answer is no. I can't do anything with 3/8. So I'm just going to write that over here. Let's focus now on our x's. So I have x squared and I have x to the first. So this turns into x to the 2 minus 1. And let's look at our y's. I've got y, same thing, 2 minus 1. Alright, so this is going to turn into 3 x's. Let's look at those. 2 minus 1, that's just 1. So I'm just going to say 3x. Same thing, y. 2 minus 1 is just 1. I can write it with or without the exponent of 1 there. I just say let's be consistent and leave it without. And there's our answer right there, gang. So we are done. Everything's good. Why don't you go ahead and give numbers 9 and 10 a shot. So pause this and then pick back up and we'll see what we can do. Okay, so let's go. Is there anything for me to do on number 9 here? There's nothing really for me to do with just this little lonesome X by himself all up here. He's just happy, having a good time. How many terms do we see in our parentheses here? Well, we see 2. I know that that's really raised to the first power. So I'm going to say here's just our lonesome X, not to leave him out and forget about him. And let's combine this. This is 2 to the first. We're raising everything. Alright, everything, if I can figure this out, is being raised to the second power. This is a power to a power, so we will be multiplying. I also see this x to the 0. So this turns into the 0 times 2. Power to a power says we multiply those two numbers together. What will this turn into? Well, once again, we're not going to mess with x. 2 to the 1 times 2, that's just 2 squared. And x to the 0 times 2 is just 0. Breaking this down a little bit more, alright, we can say that this is x over 4. And I know x to the 0 is just 1. Alright, I could say that that's 1. And 1 times 4 now is still going to be 4. So here's our answer. Let's look at number 10. Alright, let's maybe create a little bit more room here for us so that we can do that. Is there anything for us to do in the numerator? No, nothing for us to do in the numerator. There is some stuff for us to do down here in our denominator. So I'm just going to rewrite our numerator like this. And our denominator, okay, I'm going to solve that over here. So I've got 2 things in our denominator. Each one of these, alright, is going to get raised to what? It's actually raised to the 3rd power. So this should turn into 2 to the 1 times 3. And then our m to the negative 4th, we will multiply by 3 as well. So this goes 1 times 3 is 3. So this turns into 2 cubed. And negative 4 times 3 is negative 12. Let's do what our powers tell us to do here. I'm going to put a 1 here, guys, so that we know what that means. Let's, here, let me do this, just so that everybody's happy. I'm going to rewrite this in green, alright, so that we know which ones are going to combine up with each other. So, this will turn into 2 to the 1 minus 3, which is 2 to the negative 2. My m's, even though they're in different colors, are going to turn into the negative 4 minus a negative 12. That's why we subtract. We see a double negative right here. That really turns into addition. Alright, so that'll turn into addition. And so let's say we still have 2 to the negative 2 power, and m now turns into the 8th power. Should I rewrite this? And the answer to this is absolutely, but I need more room in order to do that. So if I am going to write 2 to the negative 2 power, m to the 8th, I don't have to do anything with my m to the 8th. It can stay in my numerator. If I want to move 2 to the negative 2, we merely move it to the denominator and keep it like it is. Alright, or you could say that this is 4 if you wanted to get rid of that. And you could say that it's m over 8 over 4. Either way, we are good, and that's our answer.